Hello students, welcome to our Jee Prep channel. Hope all of you are doing well as usual. Today we'll do one problem in motion in a straight line. Now let's read the problem. A body traveling along a straight line traverses one half the total distance with velocity v0. The remaining part of the distance was covered by velocity v1 for half the time and with velocity v2 for another half the time. Find the mean velocity average over the whole time of the motion. Now let us understand the methodology of this problem. There is a body who is at point A and goes to point D. It takes total t seconds. Okay. Now t seconds to reach that point D. Now a body traveling along a straight line traverses one half the total distance with velocity v0. Now AB is the half of this distance AD and this body travels this AB distance, which is x by 2, in time t1 second with velocity v0. Now body has to cover this distance BD. Now body takes time t2 second to cover distance BD, means to reach point D from this point B. But half of the time the body travels with velocity v1 and remaining half of the time body travels with velocity v2. Let t2 be the time taken by the body to move from point B to D. So for first t by 2 seconds body travels with velocity v1 and for the next t by 2 seconds body travels with velocity v. And we want to find the mean velocity average over the whole time of motion. Now what is the formula for the mean average velocity? It's a net displacement, total displacement by time required. So total distance is x divided by time is t1 plus t2. What is t1? Time taken by the body to move from A to B, to cover half of the distance where the body is moving with velocity v0. And t2 is the time taken by the body to cover remaining half of the distance. Now let's see how to work out this. Now consider the motion of the body from point A to B. Now from A to B the body is moving with velocity v0. So velocity is equal to distance upon time. v0 is equal to distance travelled is x by 2 divided by time t1, and therefore time t1 is equal to x upon 2 v0. Now we have got the time taken by the body to move from A to B. Now we have to find time t2, which is required to move from B to D. Okay. Now for the motion from point B to C, the body is travelling with velocity v1, but for the first half of the time, means for first t by 2 times, t by 2 seconds, the body is moving from B to C. So velocity is equal to distance upon time. Now here body is traveling with velocity v1, therefore v1 is equal to distance BC upon time is t2 by 2, and therefore distance BC is equal to v1 into t2 by 2. Now for the remaining distance, for remaining half of the time body is covering distance CD. So velocity is v2 is equal to distance CD upon time t2 by t1. Therefore distance CD is equal to v2 into t2 upon t1. Therefore total distance BD is equal to distance BC plus distance CD. Distance BD is x by 2 is equal to v1 into t2 by 2 plus v2 into t2 by 2. Now this t2 by 2 will come as a common factor. This 2 will get cancelled. So x equal to t2 into v1 plus v2. So therefore t2 will be x upon v1 plus v2. Now we want to find out mean average velocity. And as I told you earlier, if you want to know the average velocity, you should know the total displacement x and the time t1 and t2. We know the value of t1. X upon 2 v0, we know the value of t2, that is x upon v1 plus v2. So we will substitute this t1 and t2 here. So in here T1 is equal to x upon 2 v0, T2 is equal to x upon v1 plus v2. Take x common from the denominator. X will get cancelled. Now, therefore, V average equal to 1 upon 2 V0 plus 1 upon V1 plus V2. So, now you take LCM 2 V0 into V1 plus V2. So, this in the numerator it will be V1 plus V2 plus 2 V0 and this will go up. Therefore, V average is equal to 2 into V0 into V1 plus V2 divided by V1 plus V2 plus 2V0. This will give you the total average velocity from point A when the body moves from point A to point D. Hope you must have understood this problem. And students, if you want to perform really very well in JEE examination, I strongly recommend to subscribe our channel. Thank you.